Welcome to this tutorial in Unreal Engine. Today we will be talking a little bit about inputs. So let's get into it. So here we are inside of a third-person template inside of Unreal Engine 5, although this will work exactly the same for Unreal Engine 4 currently. So what I'm using today is Unreal Engine 5 Early Access, and the latest stable version for Unreal Engine 4 is 4.26 if you want to follow along. So we're gonna be talking a little bit about how inputs work, and we're gonna do this particular episode about how the third person character's movement works. So what we're gonna start off with, I recommend you have a completely empty slate for this if you want to learn, because we're gonna be like destroying stuff and then rebuilding it. So don't actually use this in one of your projects that you have something else done, so that you end up with potentially a broken control system or something like that. So have a fresh third-person template if you want to follow along. So here we are inside of the third-person character, and what we're going to be doing is we're going to be marking all of this event graph, and we're just going to delete it and compile and save. And then we're going to go to our project settings, and then we are going to find under engine we have something called input, and up here we have a bunch of different bindings for the input. We have some action mappings and we have some axis mappings, and we're going to be trashing all of these. So just click on the waste paper basket next to the name. So now currently we have removed all of our bindings for inputs and our movement inputs in our character. So if we were to start with our character now and go play, it will do nothing. It won't jump, it won't move, or it won't do anything. So what we're going to do now is we're going to rebuild this from scratch, so to speak, and I'm going to explain a little bit about how the input is used by the engine. When it comes to the third-person character in this case, we'll have another episode where we talk a little bit about movement for a pawn. So the difference between a character in Unreal Engine and a pawn is that the character inherits this character movement component, and it makes it much easier to have movement imparted upon a character in the world. A pawn doesn't get this by default, so it's a little bit different for that, but we'll get to that in a different episode. For now we have this third-person character. Now the first thing that we want to do is we want to have some kind of movement for this character, right? So we'll start off with project settings, and then we imagine that this character didn't have any settings to begin with. So the first thing we want to do is, let's say we want to be able to run forwards. Now one could say that that sounds like an action mapping, but when you think about control schemes in general, you tend to have, if you think about a gamepad, you have two analog sticks, one that allows you to, if you wanted to go forward you would press it upwards, if you wanted to go backwards you would press it downwards, and that's along the same axis, both the forwards and the backwards, and that's generally the thinking you should have when it comes to movement in this way as well. So what we want to impart here is we want to create an axis mapping, and we want to call this something like move forward, and this is what it's named in the third-person character to begin with. Now moving forward we generally consider to be used by the W key. So if pressing W, you can see it appears here as a keyboard. So this will be our default key. Now a little short about bindings and inputs in general. The reason why you would do an input instead of going into a character like we have done earlier in other tutorials, because we want it to be like a little bit simpler. You could go and just listen for the W key in the blueprint of a character, for example, or in the player controller. The issue with that is that if you were to have several different characters that all were controlled by the controller and all of them were listening for the W key, for example, and the W was supposed to move the character forward, and then you decide that you want to have a different key, then you would have to go in and change all of these different places instead of in one place. Another reason why this is good is because generally when it comes to games, not all players want to have the default scheme when it comes to controls. They want to be able to change some key mappings, and by doing that you have one of these bindings here that represents something like, let's say for example punch. You had an action input that said punch. Now you just implement the punch event in your characters, and then whatever key activates that event doesn't really matter, which allows for an easy way to allow the users to remap their keys, and the code will work just as fine. So it's sort of like an intermediary layer of interface between the thing that takes the input and the player that's actually putting in the input. Anyway, now that we're done with that tangent, let's continue. So what we have now here is a move forward with the key W, and then you have something called scale, and this scale is usually a value between 0 and 1 and represents what this input provides. So for example, if we were to put W here and put -1, that would mean we would actually be moving backwards. It's taking the opposite input basically. So let's press our plus sign here next to move forward and actually add a different key altogether and take the S key, which is generally what is used for backwards, and for that we will just put -1. So now we have one key that gives us scale 1 and one key that gives us scale -1. So that's good so far. Let's move on to actually using this in our character. So now that we want to move our character, we know that we've created this input axis. So we can just right click and go to events and say move forward, because that's what we created it as. And you can see that this axis event move forward is available to us. And this is the one that we want. So this, okay, let's zoom in a little bit. So this is the event that triggers, it doesn't trigger only when you get an input. This triggers, let's actually demonstrate it. Let's have a print and then put the axis value into here. Compile, save and play. So now I'm not actually touching anything, but you can see that it's just spamming out these numbers in the left here. This is just every tick, it's giving you the value that is given here, and when it is 0, that means I have no inputs and I'm doing nothing. If I was to press S, which we can also, since we have set this up, now we can actually go back and show that. So you see that it's spamming zeros here. If I hold down S, you start getting -1s, and if I press W, I start getting 1s. So that's the basis for the whole movement system. Now, to be able to use this, what we do is we right click and have an add movement input. Now, this is something that's of target pawn here, but this is something that is used by the pawns can make use of this, but what the character movement component does is it actually makes use of the information that's sent to this to pick it up and then translate it into different things like accelerations and making the character move and like handling it in different ways to make sure that the movement is just basically easy for a player to get started. When it comes to a pawn, you have to, if you don't have this character movement component, you have to do this sort of a bunch of stuff manually. And we'll be looking into that in a later episode as well, so you'll get an understanding for that. But anyway, so now what we want to do here is basically we want to have a direction to move, and we want to have an axis value to determine that. So if we were to just plug in the axis value here, that will represent our scale, so between 0 and 1. So it will take a world direction. So let's say if we go back to our world here, we can see that right, or we've created forward axis, so that's x. You can see that x is pointing in that direction, so forward plus x is in forward, minus x is backward. So let's just say that we have 1 here. This means that it will use a direction of x1 to use our scale when we get to move. So to demonstrate this quickly, now that we're back here and I press W now, you can see that it runs forward. I press S, it runs backward. And the reason why this works immediately is because we're telling it which direction is the forward vector. And this here is our input for forward. So if we at any point were to say press S key, which is on the same axis, generates the same event, then that would be -1, which means that the -1 would be multiplied against the direction, which means it would go in the opposite direction, which is minus in x value. That is why this works immediately for that. Now, there are more things happening here behind the scenes. For example, when our character moves here, how do we know how fast it is moving? Well, that is determined by a bunch of things. If you right click and type in tick, you know that, or you might know that it has this delta seconds, which is basically a measure of time that has happened since the last frame was drawn. So depending on how many frames you get per second, so 100 frames per second means that you would get a delta second of 0.01. If you had only 10 frame rate, you would have 0.1, which means that depending on the delta seconds here, you could multiply something like the speed of an object with the seconds, and that would allow you to have a smooth transition of speed regardless of how many frames you had. So if you had a spike in frames, you get like many more frames, or you get a drop in frames and get many fewer frames at some point. The delta seconds would allow you to have a smooth and consistent speed regardless of what happens with your frames, because you would be multiplying this with your speed. Now, we haven't actually set any speed, and that is because that is also handled by the character movement component. If you go to the movement component and go to, for example, character movement walking, you can see that it has a max walk speed of 600 and a max walk speed when crouched and when walking and crouched. Let's expand that a little bit so we can see. So max walk speed crouched and a max walk speed. 600 is the speed that is by the movement component being handled and multiplied by the delta seconds, and then calculating it in a direction that's getting from this add movement component. That's all handled by the movement component in the background. That's why it's so easy for us. We just need to handle giving in what scale and what direction we're going in if we want to do something simple like this. Anyway, so now we have a move forward and move backward. Let's continue with adding a move sideways. So we add a new axis mapping, because just like forward and backward, right and left work the same way. So here I can move it either move left or move right. It doesn't really matter that much, but I'm going to choose move right simply because that is the same way that the third person character has it, and it will make it will be consistent for you. So moving right for us would be the D key, and let's find it over there, and we immediately add another binding for the A key, which is supposed to be our left. So now we have the right and the left. So since we have our input saying move right, we want the right one to be the positive angle. So the D here should be scale 1. And the A, which is the opposite of move right, is to move left. It should be the -1. Okay, now we created that. So let's go back to our third person character and we'll do another move right. And when we get our axis event over here. Just like before, we can add it into our inputs, like so. And we can add our axis value in here. Now, to determine which way we're going to go here, we can go into our map again and we can see that, okay, the X direction, the Y direction here in this case is the right and the -Y is the left. So that lets us know that this value should be 1. Not like so, like so. And then we're done. So we can compile and save and we can just start playing. So Now I have the ability to run right and upwards, forwards, backwards and left, and everything looks perfectly fine because the movement component is handling so much for us. Now, what's different between this and the third-person character is that I have no ability to move my mouse currently, and I am also not able to jump. So let's continue with adding our jump first. So our jump is not like the axis mappings. A jump is just something you press a key and something happens. So that's an action mapping. So we add an action mapping and we say jump. And as default it has the spacebar. So we'll just use the spacebar. And then you see that you can also add different additional parameters that you need to have pressed for this to happen. So if I was to click in shift here, this particular event wouldn't happen unless I held down shift and pressed spacebar. Or if I had both shift and control marked, then it would need me to have both shift, control and spacebar, and I would start to have to be an octopus to be able to jump in this game, right? Now, we just want the spacebar. We want to keep this simple to begin with, but this is good to know if you want to have something a little bit more advanced, where you want to have one key do many different things. So you had one key that would do a right punch and then shift that key and it would do a heavy punch, and then alt that key and it would do a light punch. That means that you can have one key that does a lot of things, and it allows you to have multiple functionalities in it just by adding some extra parameters on it. Anyway, back to our third-person character. Now that we've created our jump event here, we can just right click here and we can type in jump, and you'll see that we have an action event here, and it says jump. So an action event has two different points in the action where it gets triggered. So the moment you press down on a key is when this event fires, and the moment you release a key is when this event fires. So some games have functionality where you trigger when you press down, and some have stuff that happens when you actually like having pressed down, but it's just when you release the key that it's actually activated. For example, if you were to have something like a Magic the Gathering, if you press down on the mouse button, it would activate the pressed key event, but you actually, by letting go of the mouse keys when you actually play the card, for example. And some other games might have where pressing down might mark something or like highlight some information, but it's only when you actually release the key that the actual command gets activated. Anyway, that's another tangent. When it comes to jumping, what we want to do is we want to right click and we just want to type jump. Now in here you can see that there's something on the character called jump. And actually we should have, yeah, you can see the description here. Makes the character jump on the next update. If you want your character to jump according to the time, blah blah blah. There's a lot of information here. You also see that it mentions stop jumping. So this is to allow, by using this and also the stop jumping, let's add that, you allow the movement component over here again to react to these things in a way where it wants to handle them. Now you can see that these are actually on a target character, meaning that they all know that they have a movement component, because all characters or all classes that inherit from character will also inherit the character movement component. Unlike over here where you see that the target is pawn, it does not have a character movement component, but these don't require a movement component to function. But still, this character, which is also inherited from pawn, knows that it is also a pawn, and it knows that it can make use of these functionalities for its functions. But this would not work out of the box for a pawn, is basically what I'm saying. So now if we compile and save, we go back into our character, and now we have made it so that our character is actually playing the jump animations and stuff like that, and it has jump functionality now, and along with its movement to the sides forwards and backwards. So now we've created a lot of movement here. What we're still missing out on is our mouse. So let's add that. And we'll go to our project settings first. And just like when it comes on analog stick that goes forward and backwards, right and left, a mouse can also be seen as having axis. You can have an axis for the mouse in the way that it moves to the right and left, and upwards and downwards, or forwards and backwards. So let's add both of these mappings at the same time to begin with. So we go to axis mappings, add two of them, and the first one for the mouse we can call this is a little bit difficult in the way, well, let's do it this way. So we'll call this one mouse right, and we'll call the other one mouse forward. The reason why this is a little bit difficult to explain is because when you move a character forward, or you have a forward there or right there, it actually moves in that direction. But a mouse is stuck to the character as the pivot point. It's moving in relation to the character. So when you move it sideways, it's not actually moving sideways, it's actually rotating sideways around the character, or moving it, rotating in upwards or downwards around the character as the center point. We don't usually have the mouse just moving away willy-nilly in some direction. Yeah, so that's why it is a little bit different in that regard. Also, I just remembered, my bad. I actually started with the project settings up here already, but if you do not know how to get the project settings found, you can find them under Edit, and down here you have a project settings, which allows you to open up this window. It's a little bit late for me to mention it now, but just in case one of you watching didn't know, that's where you find it basically. Now then, to return to our mouse input. So we have named these mouse right and mouse forward, and this is not what they're going to be named in a third-person character template. It's going to be named turn rate and look up, I believe. I think so. Anyway, so what we're going to be doing here is we're going to be doing the same. We're going to be finding a way to move the character, or move the mouse right, and this is called actually mouse in X, because again, it's in relation to the character. So you have this mouse X axis, and that immediately allows you to move in both directions actually. So we have a mouse forward, we will take mouse Y, like so, and then this is basically done. We might be coming back to this in a moment though. So what we can do is we can immediately go and say mouse right, which is our axis event that we created, and we can, actually that's the wrong one, mouse right axis event. I clicked the axis value. Might as well talk a little bit about the axis value. If we get this event first, and then we go and get the other one, mouse right. So you can see that these are sort of similar. You can see that they both have this green pin, and the reason why these are related sort of is this is the event that will trigger every time when it wants to consider mouse right. This is what you hook up to have some kind of reaction to your mouse right movement. And the mouse right here just allows you to get this axis value if you wanted to at any point. And that's what that is for. Now, when it comes to actually making use of this axis value for the character, what we need to do is we need to add our value to a rotation. So if we right click and we type in add controller, And let's see here, we're having the right words, so it should be the yaw, I believe. So like so. This means that we're sending this information further to this input here, which is a pawn, which means that all the pawns can make use of this, and also the characters and everything like that. And it's being processed, and for us that's just being the movement component handling it. So if we go in here now and press play, and I try to move my mouse around, you can see that I can only rotate, or if you have done this as well, now you can only rotate along one axis, and that's the axis that is around the Z. So this is the axis that goes up, and that's the axis where our turn rate is acting against. Now we add the second input axis, and that's called mouse forward for us. And we add a controller pitch, which is when, if you imagine a plane, it pitches up and down with its nose, and that is what this does. Now here is a area of contention, because now if I move my mouse up and down, you might immediately feel like it's rotating in the wrong way. Like if you're pulling your mouse upwards, you're let's say downwards, it's going to be looking like this. And that might be the way that you want to have the controller work, but it might also be the complete opposite depending on how much you play with flight simulator games and stuff like that. So if you wanted to change this, all you will have to do is go to your project settings and then change the mouse Y to be a -1, and that would invert the directionality when it comes to the mouse input there. So now if we were to play, the complete opposite is true when it comes to the mouse movement here. And I believe this is also how it is in the third person character by default, so it might be the one that's most preferred by players. So now we have actually created both the mouse input and the keyboard input for our character to move. And if we were to move around now, we can see that it's moving fine. But if you're playing this now with me, you might notice that it feels wonky. It's like the character is running in directions you don't want it to run in. And the reason for this is that we have some conflicts in the inputs here. The normal third-person character template is set up in such a way that, and you might not even have noticed this, that your character's camera, where you're looking with the camera, and then if you press forward, that's where it's running. But our character is not set up that way. Our character is saying that we're supposed to run in whichever direction is the X direction down here, right? So regardless of where the camera is looking, that is where the character is running in, like its local or world space, actually in this case. And that might be what you want, but it might also not be what you want. So if we go to our character here now and we check our movement input, what we can do is what they have done in the third person character template, and I will be explaining what they're doing now here so you get an understanding. So if we do what they do is they get a controlled rotation, and actually I'll show you. So this is getting the rotation for the pawn according to the controller, and they are breaking this, which is basically just exposing all the different axes for the rotation. Actually, it might be they're using break rotator, like so. And these are all float values. Now after that they do something called a make rotator, which is just the opposite of this. It's just creating one, and they don't have it connected like so. They have connected at Z, and then from this rotation they get a forward vector. Like so. And then they use that to have as their input over here. Now what this does is it will take the control rotation. Actually, let's now it's fine like this. So they get the rotation of the pawn, and then they find out which is the angle, the rotational angle of Z. So if we go back to our map again, we can see there, that means the rotation around the upwards axis, meaning the way that it's sideways is looking. You can see that it disregards totally the Y and the X. They're not interested in that. It just wants to see in what angle it's looking sideways. That sideways angle is then used to create a new rotation, which sets the other two values as 0 since they are being ignored. So you only get a complete rotator that has only the Z-axis. From that, it determines if it had this rotation, which way is its forward facing direction. Meaning that if I am looking now to the left here, that means that my forward facing direction right now is in that direction. And so if I press forward now, it will run in that direction. Now, there's a couple of things that interact to make this happen also. If you have the camera boom, and you see here it has use pawn control rotation. If we were to uncheck this and press play, then I no longer can rotate anymore. It's going to be using whichever direction the character is running at. So I don't actually have any control. However, I am still able to rotate. You can't see it, of course, but I am rotating. So now when I press forward, it's going to run a little bit to the right, and I rotate a little bit further. It's going to run further to the right, even despite... Yeah, so I'm still, by rotating, sending these inputs over here. I'm doing this mouse right input, so I'm adding control yaw inputs, so I'm actually changing which is the directionality for the pawn to be looking, so it still makes this forward vector in a different direction than it appears to be in the camera. So I'm still affecting it by doing this, but this is a little bit disjointing and it's difficult for the player to understand what's happening. So for this particular scenario, in this particular movement scheme, we want to have the use pawn control rotation so that so that they keep where does the play there, so that they keep this congruent feel about them. However, there is another issue now. Now you might be thinking I'm running backwards and forwards, but I'm not. I'm actually pressing left and right, and that is because we only changed this movement for the forwards and backwards movement. So if I press forward, I run this way. I press left, I run this way. There's a slight difference because of the angle, but you might not be able to see it. But if I keep turning, you can see that I keep running towards me if I have backwards pressed, but if I press right now, it's going to run in that direction. It's not going to care about which direction I'm moving my mouse in. And this is because we didn't actually take into consideration this for our move right. And our move right, conveniently enough, there is a quick way to get the right vector, just like there's to get a forward vector, and that's just to get right vector. And since we were using right as our movement input, that means that we can just plug this in immediately like this. And now if we run to the right, it's going to be in relation to whatever way I'm facing with the camera. So now we have actually rebuilt the... Also, before I move on, there is also a third one, get up vector, just so you know, in case you wanted to have it for some reason. This will find that what the direction is upwards in relation to the rotation. However, do keep in mind that this will be a bit broken in this case, because if this character was moving, it's just taking into consideration the Z here, which means that this up vector would always be upwards in the world, regardless of what rotation the character actually has. But just so you're aware of this, and just so you're aware of how that handles with that. Anyway, yes. So now we have actually rebuilt how the character moves and works in the third-person character. We have rebuilt the functionality that the character movement uses. Let's actually add something else for ourselves. Let's add a new action mapping. Let's add a teleport. And let's put that on the E key. Like so. Now we created a teleport event for the E key. Excellent. So type in teleport, find our action event, teleport. So what's supposed to happen when we teleport? Well, we could reuse this information. We know that we can find our forward-looking location with this. We can just drag that out here so we have that. And from that we can just put a move actor location. Set actor location. That's what we're after. So now it wants to know what is the new location. So let's just make some quick functionality here. Let's say that we want to multiply this. And this will be a little bit different in Unreal Engine 4 and 5 because by default in Unreal Engine 5 you'll get the same type as you want to multiply it with, which is a vector, but we want to have an actual float here, so we'll go to convert pin in Unreal Engine 5, but in Unreal Engine 4 you can just choose the multiply by float, like so, and then we'll promote this to a variable, and we'll just call this teleport distance. That didn't work at all, so let's try that one more time. Teleport distance. We'll compile so we can set a default value here, and let's say 10,000 should mean 10 meters. That should be okay. And we'll just drag this into here. Actually, we already have it connected over there. So that means that we get our direction, we multiply it by 1,000. That is the new position. That's the direction and the length it should be teleporting to, but we also need to add our own location because we want to have it in relation to where we are actually in right now. So get actor location, and then we add this like so, and then the new location that we're supposed to get is this one, and compile, save, go to our character. And we can now press E, and it might be difficult to see without some kind of relational information. So you can see now that I'm facing in that direction over there. I have this staircase next to me. I press E, and I teleport a little bit forward. Now, the vector that it's teleporting towards is again going to be in relation to where the camera is looking, because that is where the yaw, the movement of the mouse. If we go back here and reflect a little bit, the moving of the mouse here changes the yaw of the input, making that the pawn facing in a different direction, and that is why we get this. That's why the teleport here will also move in the direction that the camera is looking at. So there, now we have gone through, we have remade the whole third-person character template movement system. The part that we need to do, at least to make it work for the character movement component, as we've talked about. And we've made some action mappings, we've made some axis mappings, and we've also created our own little action mapping just to have some functionality to see how easy it is to build our own. And that's basically all there is to it. Hopefully you found this video helpful. If you liked the video, leave a like. If you did not like it, leave a dislike. Leave any suggestions or comments you might have down below. Subscribe and share this video if you want to see more like it in the future. That is all for now. Keep on learning. Take care.